So now that we know how to work in one-dimensional space using our number line, what do you think is a natural question to ask for extension question? Well, one of the questions we would like to ask is, how do we represent points in more than one dimensions, like 2 or 3 dimensions, now that we know how to work in one-dimensional space? So you have to look into your prior knowledge or the bank of all the things that you have so far in your head, dig deep and see what would come in handy for us to work in higher dimensions. Is there anything you've learned? The answer is yes. Did you find out what it is? Good job. Yes, we worked with complex numbers, so we can use our knowledge of complex numbers and see how we can use that knowledge to represent numbers in higher dimensions. So let's start with the Cartesian coordinate system. So the rectangular coordinate system, or Cartesian coordinate system as it's referred to in honor of René Descartes, has a horizontal number line and a vertical number line that are perpendicular to each other. The intersection of the two number lines is called the origin or reference point, and we label it as 0, 0 in parentheses. The left-right movement is our x-coordinate, and up-down movement is our y-coordinate, and we denote all coordinates in rectangular coordinate system or Cartesian coordinate system as x, y, surrounded by parentheses. So the first coordinate is x coordinate, which is left-right movement, and up-down movement is the second coordinate. The first coordinate is also sometimes referred to as the abscissa, and the second coordinate as the ordinate. So how do we plot points and figure out how to move around in this two-dimensional space? Well, let's start at 0, 0, and if you go 6 on the positive direction of the x, and let's say we go up 2, what do you think we should label this coordinate as? Pause the video here and see what you can label this coordinate as. We would label it as 6, 2. 6 is the horizontal direction and 2 is the vertical direction. The right-hand side of the horizontal number line is positive, left side is negative, up on the y-axis is positive, and down is negative. All right, so multiple points. If I want multiple points, well, I can just use x, y for both or more points, so I'll have to use subscripts. When you run out of variables, mathematicians use subscripts. So x1, y1, that's x-coordinate of the first point and y-coordinate of the first point. x2, y2 would be second coordinate, and so x2 would refer to the x-coordinate of the second point, and y2 would refer to as the y-coordinate of the second point. All right, let's make sure that you know how to navigate in our two-dimensional space. So again, make sure that the coordinates are written as parentheses x, y. X is the left-right movement, and y is the up-down movement. Let's see what you can do then. So already we saw that the intersection of the two lines is our origin, so 0, 0. And then from there, we can move left, right, up, down. We saw that if we go 6 to the right and go 3 up, that we will be at 6, 3. So how about you figure out what the coordinates will be for this point right here that you see? Go ahead, pause the video and label it. Good. -2, 2 would be the labels for that one. How about that one? Because you don't have a finer grid here, you'll have to estimate. Go ahead, estimate the coordinates of that point. We can say it's 3.5, 2.5. All right, go ahead, pause the video here and see if you can plot the following points. Go ahead. This is important so you understand how to orient yourself in this coordinate system. Assuming you've come back from plotting the points, let's take a look. See if you match the coordinates that we have here. Did you get them all right? Otherwise, make sure you understand how to navigate. For example, -6, 5, which is the point right here, -6 on the x, and up 5 for y. All right, the remaining two problems, pause the video and see if you can label. So I'm giving you the coordinate, and you tell me what the coordinates will be. Go ahead, label this coordinate. Good. What about this one? Good. So now we know that our space in 2 dimensions can be broken into quadrants by the x and y axis. Quadrant 1 is xy coordinates are both positive. Quadrant 2 is where x coordinate is negative, y is positive. Quadrant 3 is where both x and y coordinates are negative. And quadrant 4 is x positive and y negative. So let's see if you can think about how to extend our 2-dimensional coordinate system to 3-dimensional coordinate system. Clearly, we will need a third axis. So the space, the 3D space that you inhabit, if you want to understand that space, it sometimes helps if you can create a coordinate system in which you can move around. So we need our extension of our 2-dimensional coordinate system, which had 2 perpendicular axes, and the intersection of that was the origin from which we went left and right was x, and forward, backwards, or up and down in 2-dimensional space was the y coordinate, or the y-axis, and their intersection of the 2 axes was our origin. So in our 3-dimensional space, we will need 3 perpendicular axes. The intersection of these 3 axes will be our reference point, which is right here, and we need to figure out how to represent these coordinates then in the space. So once you have the anchor or the origin, the axis that comes towards you, the red that you see here is our x-axis. Our coordinates coming forward to you is the positive x direction. Going back would be negative x direction. Going to the right will be positive y direction. Going to the left is negative y direction. So going up would be positive z direction, and then going down would be negative z direction. So we need to represent these coordinates, so we'll use triplets. And so we'll start with 0, 0, 0. So 0, 0, 0 will be our anchor. The first coordinate is my x values, second coordinate is my y values, and the third coordinate will be my z coordinate. So for example, 2, 0, 0 would be the coordinate where you just moved 2 forward in the x direction. So if I said, let's say I want 2, 3, 0, so I went 2 forward, and then 3 to the right, and still I'm in the xy plane. And then if I add a z coordinate, say 4, so it'll be 2, 3, 4, then I will be going up from here. So that will be this coordinate here, d, which is 2, 3, 4. 2 in the x direction, 3 in the y direction, and 4 in the z direction, or up. So it's like if you're sitting in a room, the corners where the room, in one of the corners will be your 0, 0, 0, and then you can move, orient yourself in space based on that anchor. And so for example, see if you can plot the coordinate -2, -4, 4. Where do you think in space, in the coordinate system you see here, it will be located? So pause the video here and see if you can locate the coordinate -2, -4, 4. Go ahead. All right, assuming you've done that, -2 is the x, so that means you'll go back 2, -4 for the y. So left 4, up 4. So that's where you will plot the coordinate. What about the coordinate 2, 3, -2? Go ahead, pause the video and see what you can do. So that will be 2 in the positive x direction, 3 across for the y, and then -2 down. So it will be here. So you can orient left, right, forward, backwards, and up and down because you have a third dimension to move in. Just out of curiosity, what do you think will be 4 dimensions and 5 dimensions? Then you need to have that many coordinates. So if I have 4 dimensions, I'll have a quadruplet. So it'll be x, y, z, w. If you start running out of letters and dimensions, then you just start using subscripts. x1, x2, x3, x4, x5, x6, x7. And so basically you can have as many dimensions as you want. And so a lot of physicists and a lot of mathematicians will look at multi-dimensional quantities. And so it's not just restricted to 3 dimensions. So a lot of the ideas that you talk about are studied in the field of mathematics. You can work in real analysis, geometry, topology, all these different disciplines in mathematics study multidimensional spaces. So it's a lot of fun just to think about how to orient yourself and imagine how to plot these points. The 3 dimensions is the space we live in, so it's a little easier to see. When you go beyond 3 dimensions, it's a little harder to see what happens to 4th dimension or 5th dimension. So you need to cultivate an amazing visual imagination so that you can understand these multidimensional spaces. But you can see how mathematics consistently just wants to keep growing and growing because our imagination is endless.